Good afternoon, everybody. Welcome to another episode of Dispatches from the Energy Transition. Dispatches explores the real world application of new technologies and their impact on projects. We have a lot of interesting guests on our series, people that are making an impact in the energy transition on a daily basis. Today, we have episode 20, 1 week before Thanksgiving. This is a very interesting project that I got to work on with Outfit, filmed the project, designing resilience, the Orcas Center Microgrid on the San Juan Islands. I'm Robert W. Cross. I'm the principal of Outfit. We're a design studio that focuses on B2B marketing in the CNI segment. As always, I'm very thankful to be joined by Lucas Miller, senior engineering consultant with Mayfield Renewables. Lucas, Mayfield worked on this project too, correct?
Correct. Thanks, Robert. Yeah, so Mayfield is a engineering consultancy. We're mostly focused on mid-market solar, battery, and microgrid projects, much like the one we're going to talk about here today. And we also offer some technical education services, both pre-recorded online classes, conference trainings, and private custom classes for teams. But like you mentioned, Robert, we were fortunate enough to be the electrical engineer of record for this project. So we're very familiar with how this one went, really excited to review the whole process, talk about some lessons learned, and hear from some different stakeholder perspectives as well. With that, we're joined by a couple of those key stakeholders. So first off, let's start with Markus Virta from Cascadia. Markus, thank you so much for joining us. Do you want to do a quick introduction?
Sure. Thanks, Lucas and Robert, for having us. My name is Markus Virta. I'm the co-founder and managing partner at both Cascadia Renewables and Sulis Energy. We at Cascadia originated this project and worked really closely with stakeholders in the community at the Orcas Center, and then amongst emergency management and utilities and the permitting AHJs to make this project happen. It's been couple year process, and we're really excited to dive into the details today.
Great. Thanks, Markus. We're also joined by Aaron Bowman, president at ELM MicroGrid. How's it going today, Aaron?
Good. How you doing, Lucas? Thank you guys for having us. Really excited about this conversation today. This was such a great partner, great project, and with great partners like Cascadia and Mayfield and Robert. Always great to talk to you as well. So excited for the conversation.
Well, let's get started with just a little bit more info on kind of ELM and Cascadia, and maybe starting with you, Aaron. Give us a quick overview of what ELM microgrid is and how you fit into this broader ELM family of companies.
Sure. Yeah. I'll start with ELM companies as a whole. ELM is a family of four companies. Lee Graves, our CEO and founder, started ELM 27 years ago in 1998. And we're a privately owned US-based company with a little over 1,500 employees across all of our family of companies, all focused in the energy sector, mainly on either utilities or distributed energy, like ourselves with the microgrid systems. The ELM Microgrid Group, myself and my partner, Jason Petermeyer, started this division 11 years ago. We started out doing microgrid controls and have grown into doing full packaged microgrid battery energy storage systems. As you can see in the pictures on the screen, we have a 125,000 square foot facility here in Texas, where all of our engineering, manufacturing, and customer support takes place. And we have a full manufactured, U.S. manufactured microgrid battery energy storage systems, like the ones that are on the Orcas Center. So it's been a lot of fun and a lot of challenges to not only grow as a company, but grow with and as an industry. So it's been really interesting to see where the world of microgrids has come in the last 11 years. So sometimes it feels like we've been doing it a long time, and at other times it feels like it all just started yesterday. So it's pretty interesting.
Right. I know we like to call it the solar coaster, but I think we should probably just expand that for storage as well. I did want to ask you just one more quick one, Aaron, and it's been a buzzy topic these days, but FIAC, so foreign entity of concern, domestic content. You mentioned American-made content, but if you can give us a quick overview of where
Yeah.
you guys fit into that puzzle.
Yeah, absolutely. We're in an interesting position because from the beginning, we were working to make all of our product as made in America as possible. And we did it out of a blend of, we did a lot of industry leading projects as far as technology challenges. And so, in order to be able to be on the forefront with our technology, we really had to keep as much of the manufacturing local as possible. So all our enclosures have always been made in the U.S. We've always done all of our assembly here in Texas in the U.S. Our subcomponents, like the inverters we use from like EPC Power, a U.S. made manufacturer for inverters. Our control systems all developed here in house. So we were really doing it to be reactive to the market and then finding ways to be competitive at the same time. And really, operating in kind of the 125 kW to 10 megawatt space as far as our microgrid packages go. And so, when everything started happening with FIAC and the tariffs over the last couple of years, we found ourselves in a great position because we did it to be competitive. We also did believe, being a US based company, that we wanted to have as close a relationship as possible to our suppliers. So, the battery cells themselves and the modules, we still source those from overseas. It's pretty tough to find those, especially from a tier one manufacturer that's bankable, not made overseas. So we still have that component, but the entire rest of our system is manufactured in the US. So US steel on the enclosures, our cooling system is made by a great partner, Dantherm in the Carolinas. I mentioned EPC with the inverters. So we do meet both FIAC compliance with that and the domestic content on our larger systems. And we're working with manufacturers to bring more of the battery cell and module manufacturing here. So our next step that we're working on is to try to bring just the cells into the US and make the modules here in the US. So we get the rest of the components around the battery, like the cooling plates and enclosures and things like that. So it's a constant process for us. Those FIAC rules and percentages are climbing over time. So we're not only, satisfied with where we're at today, but we're already looking out to the future. So our product today is good through 2028 with the FIAC rules and the domestic content, but we know we've got work to do for 2029 and beyond. And we're working on that today. So it's definitely a challenge for everybody in the industry. But like I said, our long-term strategy paid off. So it wasn't an easy road, but sometimes you find the hard roads end up being the best in the long run, and that's where we're finding ourselves. So pretty exciting times for us, actually, while a lot of others in the industry have been challenged. So,
Aaron, I have a follow-up on that. I've been really impressed with ELM's approach to business and partnerships and the work that you've been doing. If I'm a CNI project developer and I'm trying to navigate this landscape, how does ELM work with your clients, like to deal with all this? Like what recommendations would you make?
Yeah, I'll be honest with you. First step that we really like to see is that they're bringing together the right team of folks that know what they're doing. So, one we recommend a lot of times is, where are you at in your engineering process? And if they're pretty new to it and they haven't gotten into that, we recommend like Mayfield a lot, right? We have some engineering partners like Mayfield that we've worked with that we really recommend that they go to. Working with folks like Markus, we started to work together several years ago now, and it's really an iterative process. We've got an entire pre-sales support team on our side. We've got sales engineers. We've got public policy analysts to look at different regions and what the rules are. So it's a constant motion. And really a big part is contact us first. People want to wait, think they have it all figured out, and then call us when they think they're ready to place an order. And because I think we're not going to want to deal with them until they're ready to order equipment. And it's actually quite the opposite. We'd much rather have early conversations with folks, try to help guide with our experiences, lesson learned. Maybe if we see holes in what they've got in their team, guide them to other folks that can help them with the project. And we're fine with, and Markus can attest to this, it's quite common. We're talking to our customers about projects 6 months, 9 months, even a year before we actually get our portion of the order on the project. And our reasoning for that is it's a lot, believe it or not, it's a lot easier to do it that way than it is for us to be after a customer's down the road, has drawings approved, has started putting in for permits, and then they come to us and we have to share with them some bad news of, oh no, you looked at that wrong, you read the specs wrong, you didn't understand how this interconnect has to happen. That's a lot more work than if we spend the time up front. So that's the biggest thing, is communicate with us early and let us help you even pre-sale. And we spend a ton of time doing that, but it's well worth it. So that would be the number one piece of advice I have, is reach out early and often, pre-project. So.
Yeah. Markus, good to see you. I think we saw you last week in Bellingham. I think it's been great to get to know Cascadia Renewables. I think you guys have a real special company and a mission. Talk to me a little bit about the technical economic community, this three-pronged approach that you guys take to project development, that I think the audience would benefit to hear about.
Yeah, thanks, Robert. And I just want to echo back the sentiment that Aaron made. I think we, started out, so Cascadia Renewables formed in 2022, and we formed about a month after the Inflation Reduction Act passed, with this kind of sense of urgency and this idea that we really need to focus on public-private partnerships in the context of load growth and the toolkit that our industry can provide in clean energy and resilient energy development. And so we have been working through kind of iterating on our feasibility process, knowing that these complex microgrids really deserve a thorough and detailed analysis of the kind of life cycle of the project and risks and mitigation strategies that go from taking an idea and then building conceptual designs and a contractor team and an engineering team and a equipment supply portfolio to deliver these projects consistent with the community and their goals. And so how that's manifested is, looking really closely at the technical, economic, and community-based feasibility of a project. We like to call it the three-legged stool, in that oftentimes we'll see, quotes from installers or kind of lopsided feasibility analyses that don't really thoroughly investigate, all three of those legs to the stool. So it's important to not have too much hubris here. I think we really try to reach out and work with great partners like ELM, like Mayfield, like Zendy, and community partners and community-based organizations that really know their communities, to understand the problems they're encountering and what risks might be posed by a project, and then taking the time to really investigate how to de-risk those hurdles and deliver a project within the context of available funding, budgets, and timeline constraints.
Thanks for that, Mark. I just was curious a little bit. Lucas brought up a good question in our prep. You guys have Sulis Energy as well. Can you talk a little bit about the relationship between the two companies, and as a founder and an entrepreneur, kind of the opportunity and the challenges you face of getting these companies moving kind of synchronously, right?
Yeah, it's a question we get all the time. We founded two companies intentionally. Cascadia Renewables provides kind of early stage development services to local governments, tribes, nonprofits, C&I clients, and utilities who are interested in owning and operating projects. So we look a lot like a traditional developer with design kind of capacity in-house, but we're different in that we don't own and operate assets. We empower communities to own and operate assets. Sulis is different in that it's a construction management company. It's a general contractor, effectively. So why not vertically integrate them? You know, I started in this industry 15 years ago, and I've seen, you know, it's a kind of time old tale today of folks that got a little bit too big, vertically integrated, and fell over in this industry. And so we really were thoughtful when we were founding these companies about what were the core missions that they were trying to deliver and what skill sets were needed to be experts at delivering kind of the focus needed to meet those missions. And we realized, you know, coming from the EPC world, that construction and construction management is often a different skill set than development, economic, technical, and community engagement and analysis. And so we separated the companies for a couple of reasons, but primarily it was focus and trying to make sure that we really had a world-class team in each business that could deliver on what it was promising and not get too big or too distracted by the stresses of the entire process.
Thank you, Markus. Let's dive into the project. So this was a thrill for me. I actually got to fly out to Orcas Island and film the project for Zendy and Cascadia Renewables with the Outfit earlier this fall. Dmitry Stankovic is the former executive director of the Orcas Center. And I kind of want to center on this quote a bit. Most of the time, it feels like we're on the mainland, but in a large-scale emergency, we become very isolated here. And when we think about energy, and we think about power and our day-to-day lives, I mean, number one, we tend to not think about it unless we don't have it. And in this instance, when you take a look at the island where it's situated, there is a degree of vulnerability here. And it's pretty important to be able to Markus Island on an island, but talk a little bit about how this project came to light. You know, I thought it was super interesting, the emergency management component that you emphasize. Why don't you walk us through it a little bit at a high level?
Yeah, so this project came to us when Dmitry had reached out. He had gotten some bids from a really experienced local installer who was helping them with a solar and kind of high-level storage design. And when he kind of kept working through what they were hoping to do with this project, that installer realized that really what they needed is not a construction estimate or proposal, but a detailed feasibility study. And so he brought us on board, and we helped him get a feasibility study put together for the project that really tried to weight 4 components on the project. Through the context of that three-legged stool, so the economic, technical, and community-based feasibility, we were looking at kind of what are the constraints of the local grid, what are the needs for utility operations. You know, the scope of emergency management is interesting, and that we were, you know, chatting with the emergency manager in Orcas for all of the islands, and realizing early on that sometimes the best resilience hub isn't where you would think it would be, but where the community is already gathering. So, you know, we reviewed the San Juan County Public Comprehensive Emergency Management Plan and understood what hazards they were preparing for and what emergency support functions were needing to be covered by this facility. This facility specifically was a joint command center during COVID, and it was a vaccination clinic. So it already had a history of providing really critical support to its community. And then also looking at the 2 other kind of components, kind of what is the growth planning and comprehensive planning and siting and zoning constraints for a project? And then finally, how does climate change add chaos to all of that? And what climate adaptation measures should we be thinking about as we're developing a project? So I think it was through those lenses that the community resilience and energy as a function of community resilience became really apparent to Dimitri, to the Orcas Center, and for us in our work. So the first step for us was really trying to define what resilience meant to them. And I can just tell you honestly, without Dimitri, without a really strong community anchor, this project would never have happened. He's rooted in the community. He really knows well the fire marshal, the utility folks, the county zoning and siting AHJ, and then of course the emergency manager. And it was bringing all of those stakeholders together to start to think about how could this project serve the community, pound for pound, and how could we leverage the programs that were available to deliver that project, is where the rubber met the road.
I just want to touch on this a little bit. That's really great context, Markus. You and I often talk about the dual benefits of resilience, which you spoke to, and reliability. But what really struck me in having these interviews on site and just talking to people around the system, and first off, the system is literally in a community hub, right? So the Orcas Center convenes classes, arts, a lot of different stuff happening, and then right behind it is a soccer field where people are practicing. And I think Cascadia, Mayfield, ELM, when I think of your guys' companies, you all do a great job of educating and getting out there. And when these projects are happening, it's pretty impactful to see how people talk about them and think about them. The word that kept coming up in interviews is confidence. Confidence in having a system and distributed generation on the island. Can you talk a little bit about that word, confidence, and what it means to you on these projects?
It's really important. I think we like to talk about how these microgrid projects come together. This one particularly, could be defined as a simple microgrid, but for anyone who's actually developed and constructed a microgrid, they know that's naive. Every microgrid is bespoke and incredibly complex. That said, the vision here is to be developing these anchor microgrids in communities where we could help to build more in the future and help to, not only prove the concept of microgrids that are quickly becoming more mature and commercialized, but to think about how could we spread kind of community-based or multi-node microgrids that are networked across distribution circuits. And that's a vision that this community shares. And, I think it was actually Clean Coalition that had first done a larger community feasibility study on it that inspired that vision for us. So, at the end of the day, it really colored how we chose partners on this project. Why we wanted to work with ELM is a big part of it was confidence, knowing that they had delivered microgrids in island communities, that they had vertical integration with their BMS and their microgrid controller, confidence in Mayfield and knowing that they were specialized in microgrid engineering and design, in the electrical contractor and Mills Electric and the civil contractors. There's an incredible amount of challenging work on this project. And so we realized early on, in order to pull this off, we really needed to find the folks who were not only excellent at what they do, but also had the local knowledge to deliver on time and in budget, a scope that was always ambitious.
Yeah, and one thing I do want to add from Mayfield's perspective here and why this one was really, I think, special for our team was that our CEO, Jacob, actually grew up in this community and was born and raised on San Juan Island, which is next door to Orcas Island. He went to school. He probably played soccer on that soccer field right next to the Orcas Center, attended school, plays in the Orcas Center. So it really hit close to home compared to any other project that I think we've ever worked on. So that part was really cool to see.
And I think to an extent, Lucas, like this is a good pivot into community engagement, but that's always going to be a case, right? Like wherever a project's built, it hits close to home to someone. And so kind of our philosophy there is to find that someone, to find that anchor, in the community that's really, well connected, and to do the work of listening up front and understanding what the goals of the community are, and how a project can best represent them. I think what's so exciting about microgrids is that they're inherently providing benefit and value, in front of and behind the meter, regardless of where they're interconnected. So, while the primary goal and function of the Orcas Center Microgrid was resilience and ensuring continued power for emergency management services and mass care for the community, it was also grid services, right? And Opalco has a single submerged cable that feeds the entire chain of islands, and they feel that demand management and that demand problem manifesting in the islands where there is a high penetration of EVs and inverter-based loads already. So the microgrid here was a no-brainer to all of the stakeholders, because it not only provided shelter in an emergency, but also provided daily optimization and management of power in support of their cooperative utility.
And I think if I can add into that just a little bit, because we do these systems all over, not only the US, but we have in the Bahamas. So we have projects like the Orcas Center. I was just in Spokane at the MLK Center 2 weeks ago, very similar microgrid to this, only grid tied, not in an island like this. But we have ones out east. There's one at a facility, I think it's called Sweaty Falls. Very similar type situation. And the key we try to do from ELM, and Robert, you were asking about how we go out and partner with people. We don't try to come in ELM as ELM and do these entire microgrid projects. We focus on a part of it that we know we can deliver consistently. And as Markus said, each one of these projects is bespoke. But what we try to do from our product side of things is the things that we can make common across all these microgrids. We've really strived to try to do that. So to Markus's point, while this project is bespoke as a system, the system Markus has deployed here at Orcas is almost exactly the same as the one I was standing in front of 2 weeks ago in Spokane at the MLK Center, is exactly the same as the one that we shipped to the Bahamas about a month ago. From a standpoint of the base ELM microgrid package, which is our controls, the storage inverter, the battery storage system, and the whole package system. So we're able to commonize core parts of it to try and make folks like Markus's life better. But then what we do is go partner with folks like Cascadia, who are regional, because they're the ones that understand the community that it's going into. They're the ones that have the relationships with the folks that are at the fire department, in the permitting office, at the facilities, and understand what needs to be unique to the community. So we try to really build these partnerships with folks like Cascadia, so that we can get these systems out in the field doing the most good, but in a manner that operates efficiently for that community. So I think that's a key part of it. You cannot undervalue the relationship piece of these systems going out in the field and being effective. I've seen others where national companies have tried to buy from us and go do this on a broader range, and they don't have that community connection. And quite honestly, I see the systems with folks like Markus and Cascadia and Sulis. Their projects move to execution, delivery, and operation in almost half the time, a lot of times, that I see bigger corporations that try to buy our systems and put them in. So that community engagement is so critical, because there's so many people involved that have an opinion about this technology. And it's about, they're using these places, right? So you can't come in and miss the mark. You got to come in and hit the nail on the head, because people expect that when they turn on the light switch, the lights come on. Whether the grid's connected or not connected, all they want to know is that the power's on, because they need that facility or they need that space. So it's really critical.
It's such a good point, Aaron. I think, like, not to quote Mike Tyson, but everyone has a plan until they're punched in the face. And when we talk about commercializing microgrids, what ELM has done is standardized as much as you can, I think, from the manufacturer standpoint, which is critical, because the emergency manager and the folks at the Orcas Center are depending on this for life-giving support in an emergency, right? When the big earthquake happens, or a large outage, an emergency happens, they're not likely going to have time to open the operating manual. They need a technology that's consistent and reliable, that allows them to continue providing the services that they do out of that facility. So finding partners that recognize that have delivered microgrids in that emergency and resilience context is critical. And then also not taking for granted the role that the community has to take in the operation of that system is critical, right? So finding that anchor in the community that recognizes the lifetime O&M requirements on that product and what the operational constraints of it are, is how you actually manifest the value and the benefit of these projects.
Yep.
Without that plan, it's a really, really expensive box sitting outside.
That's the next part I was going to add, Markus, and this is where the partnership amongst everyone comes from, ELM to Cascadia is the system's now out there, it's installed, it's successful at the Orcas Center day one. Now it's supposed to operate for the next 20 years. And that takes a partnership between the company that provided all the product and technology, not just ELM, but the other components of the system. The partner that put it in the field and installed it is now providing the service and support for the next 20 years, the PMs, any warranty issues, things like that. And then again, the end user understanding there are some unique things to how this is going to operate and being prepared to support that as well. So it's a real relationship that has to be built, because it's a marriage for a long time. And it's not just for us, it's not just, okay, great, that unit went out the back door, next. No, that's the beginning of this. So.
Well, I want to ask one really quick question for you both, and then I think we can move on to kind of project development for this one. And we've talked a lot about internal champions, I think Dimitri being a key example in this case, but we won't always have one, right? And we're seeing more and more vast moratoriums, more and more pushback nationwide. In your quick response here, how would both of you kind of tackle those areas where maybe you have some loose interest for a project, but at the same time there's a lot of community pushback? How do you ease fears, work with the community, kind of change mindsets to enable more development?
I can start. I think you can't rush through those community concerns. Like, you have to validate, because oftentimes they're really valid concerns. And we found success in just slowing down and taking the time in feasibility to listen to the community and recognize, that there's an educational aspect to development that is bidirectional, to take an industry term, right? And we need to understand and learn what the priorities are from the community. And that could mean what their concerns are around fire mitigation, around deflagration, or around something that may not seem appropriate or relevant to this project, that is still on top of mind for the community. Only when you get all of the facts can you start to be creative around solutions. And so I would really urge folks wanting to get into this to think about not selling solutions, but solving problems that are rooted in communities. And you can't solve those problems unless you start by listening.
Yeah, I think the other thing I'll add in there is, one of the things we're constantly doing is working on continuing education. It's you're not going to win every battle, and sometimes that happens. But the more of these systems we get out in the field, the more we get being successful. The more we can go out and work with like the local AHJs to have them have a comfort level, because they're folks in the community as well, right? So you're going to need small communities. And I mean, I grew up in a smaller Midwestern community. The guy today in the hometown I'm from, the guy today that's the fire chief, I went to high school with, right? So if you have, those people who are trusted community members that might go to that meeting and speak up and say, hey, as the fire department, we're not concerned about this. You kind of have to build relationships and trust in different segments of the community, because I can come in and tell somebody this system's safe and they don't need to worry till I'm blue in the face. They're not going to listen. But if Bob, who's the police chief, who they've known for 40 years, says, no, I've researched this. We've done some, meetings on this. I've talked to others. This is safe. They'll go, oh, okay. Bob says we're good. So, right. There's different, you have to build different champions within the community to really, and sometimes that just takes time. And there's just no way around it. I've seen that pre-project phase I talked about. I've seen that take 2-3 years at times, and that doesn't mean to discourage people, but Markus can attest. That's just sometimes you got to work through these and really be committed to this could happen. But then we see things where one in one community, then the next community is more careful, more considerate of it, or more comfortable with it, and so that's the other thing we see is we'll see it take forever for the first one of these systems, or maybe the first two of these systems, to go into a region. But then once those 2 or 3 are in the region, then all of a sudden we see 15, 20, 30 happen in that same region, which is what's been happening in the Northwest actually over the last probably year. But I was out there, I've been out working in the Midwest pitching microgrids for 8 years. And we've put more systems in the Northwest in the last I think year and a half than we did in those previous 8 years. So it's a lot of education, a lot of relationship building, and that's between multiple levels involved in the project.
Great. Yeah, I think one thing that we've found is getting a fire marshal to buy in goes maybe longer than any other champion you could ever find. Like they're a neutral arbiter, they're trusted. If they have an emergency response plan in place, you're much more likely to install things in that area. So definitely one avenue to look at. Who's responsible for that education is another question entirely, though. And how the community that gets that buy-in is a separate piece of it, but maybe for another day. We do want to keep moving. So I want to maybe turn it to you here, Markus, and talk a bit about battery selection here. What functions were you looking for on this project, and why ELM was what you landed on?
Yeah, I think when we were first specifying this project, I think this was, probably RE plus 23. And we looked at, I'm not kidding, 80 different BESS suppliers at the time. I would guess half of them are not supplying BESS anymore. So we knew we wanted a legacy partner that was really committed to microgrids and microgrid controls that had some vertical integration. When we started asking around to some of the larger battery module and cell manufacturers, we learned some concerning facts about their ability to warrant projects in salt environments. And so that ELM had deployed projects in the Caribbean, that had deployed projects in island environments, that had an awareness of what salt air can do to equipment, and was open to warranting with provisions made. The project was just the first hurdle of many. But I think we've probably talked ad nauseum already about how important this partnership's been, and ELM has been committed since really early on in the full scope of it. So, for instance, Opalco is the serving utility in this instance, and they were really interested in landing a fiber optic cable in the microgrid controller to understand and study how the microgrid operates, and how they could potentially support the dispatch of that microgrid for grid services and grid support. ELM has a really long, track record in utility services and a fluency in integrating with utilities. That was important to us. It was important to them, and it was important to the stakeholders. So there was alignment there, which made the decision easier for us. The logistics of getting, a 20,000-pound battery to a remote location aren't lost on us, and ELM was really supportive in in that process, and then in also making sure that we had technicians who could come out from ELM to support commissioning of the project, alongside our team was something that mattered to us to, ensure that not only was the project commissioned properly, but that we had all of the relevant training on site for the folks at the Orcas Center to know, left from right when it came to operating the microgrid. So, it wasn't just one thing. There were a myriad of things that make a partnership great. And I think ELM checked all those boxes for us.
Aaron, I have a question. I've been studying software the past 2 to 3 years in regard to project development industry. Can you talk a little bit about the importance of interoperability with hardware and software on complex projects like the Orcas Center?
Yeah, absolutely. I think the one thing that really, when you were talking about the flexibility of what makes these projects possible, and Markus was talking about every project being bespoke, and I talked about how we try to make the baseline of our product the same for everyone. Where we're able to create that flexibility for the bespoke nature of every microgrid project is through our software. For the biggest part of our IP, everyone sees our boxes. They see, the big ELM units with the batteries and the switchgear and all of that we build and deliver. But the key, the engine that makes this all go is our software, both our field site edge software, ELM field site edge software we've developed in-house, which sits hardline at the site, hardwired to all the components, not only our battery storage components, but things like the PV inverters, the generator, and that's where all the decisions are being made. So they're hardwired decisions being made. The intelligence is at the edge, not relying on internet connection, not relying on someone dialing in to tell it what to do. And within that, because we have all of our software, all of that software development 100% in-house, we have the flexibility to then adjust to the project's bespoke needs. So, we've built out libraries and continue to build out libraries of drivers for every PV inverter in the industry, every generator in the industry. We're able to tie into, say the SEL relay for the grid disconnect relay. But then also we can tie in with things like the utility. Quite often different utilities have different requirements. They want to be connected into the battery system, and we can provide that flexibility to be able to give that connection, to be able to do that communication. We also, what you're seeing on the screen right now is our cloud backend, which is hosted in Microsoft Azure, which does all the data historian, the reporting, the real-time monitoring that not only we can look at on the web, but Markus and his team can look at on the web, the Orcas Center can look at on the web. So the ability to be able to put in those hooks as different components come in, that's where the flexibility has to be. And I think that's what Markus was alluding to when he was talking about being vertically stacked. It's a lot easier when we have control of all those components to be able to sit in a meeting, and Markus and his partner have done this. He's sat in a meeting with myself and Jason, or even some of our engineers, and like, could we do this? And we look at it and go, well, we've never done that before. And then we start a design review right then and there. And a couple weeks later, we're like, hey, we think we have it. Let's test it. And then what's great is partners like Markus bring that. That's how our technology advances. Like a ton of our advancement over the last 10 years in our product and our software has all come from simple requests from partners like Markus or like an engineer at Mayfield who are like, hey, could you guys do this? And we're like, well, we never thought of that, but I see why you guys would need that. Let me see. So really that flexibility in software is really where you have to have that flexibility and an openness and a willingness to partner from that standpoint. So, and we try to do that too in a way where we're not nickel and diming people either. So we don't come and say, oh, that's a million change requests and, all these sort of things. We try to really blend that in from a standpoint of working with our customers on that within reason. Obviously, you have some that are, we do say no sometimes, so, but.
Thank you, Aaron. Markus, we talked about some of the hurdles in project development. And I thought it was really interesting that you and Callum, started your own feasibility and then got introduced to Zendy. with the study that you did. Could you talk us a little bit about trying to mitigate risk through feasibility before entering project development, and then some of the hurdles you faced on this project?
Yeah, so like I said earlier, this project was originated by a really excellent local solar contractor that was originally looking at a roof-mounted PV project on the kind of main roof of the Orcas Center. When we first got involved, one of the first things we did was a structural analysis on that roof, and lo and behold, there was some structural issues that wouldn't support the PV to be up there. So we quickly, pivoted to contingency plans and kind of redesigning what the PV could look like in the context of resilience, survivability, and autonomy in their emergency management efforts. So that was like a clear, obvious early hurdle. And there were, of course, manifest hurdles throughout the project. From the civil scope that was pretty detailed. We had to remove some large trees to the south of the property. There was grading that went into this, as well as a new bioswale, quite a bit of underground utility work, and then new concrete pads and fencing, and then the array all built within a glacial tilth kind of geologic zone. So some custom racking systems were deployed to ensure that the PV went in smoothly. When we first set out on the kind of electrical analysis to justify the DER asset sizes for the project, we had built our own three-phase system sizing tool, looking at locked rotor amps on all of the motors at the facility, and trying to understand what load shedding protocols we could deploy. At that point, we hadn't used Homer or Zendy, and got introduced to Zendy by Michiel Zoidweg, who's a good buddy of ours at MZ Solar Consulting. He did some design analysis on our hand calculated numbers, and helped us to re-optimize the system in Zendy. Fortunately, everything came out consistent with our hand calculations, which was great. But it was another one of those moments that really, I think, reiterated how important partnerships are, and recognizing that hubris can really get in the way when you're trying to do something that's first of a kind. So, part of that was us recognizing we should be flexible with our budget, and that there's a time to reinvest dollars that you would have otherwise earned into partnerships to make sure that the project goes smoothly. And yeah, I think there's a lot of that could have gone wrong that was anticipated beforehand because of those partnerships early on.
Well, I see we're getting a handful of questions more on the engineering side, so I think let's move into that. So we've got about 10 minutes left here. So just kind of quick overview. We just showed a few photos of the site, but kind of what we're working with here with regards to the overall site layout. On the left here, you can see just an overall site plan from our Mayfield sets that we developed. And then to the right is the real world look at the system. We co-located all equipment here. So the array, genset, BESS, all located on a pad right adjacent to the PV array with underground trenching to the facility itself. Markus, maybe let's start with you here. And I think there were a couple key points we want to make, maybe first on kind of setbacks, fire code considerations. And on the next slide, we'll take a little bit of a look at controls. But this was initially located in an area surrounded by trees, vegetation, shrubbery. We can also see toward the bottom of this visual, we have a public right of way. We have this little walkway and a school to the other side. So with that, we had to adhere to many different setback requirements. So kind of walk us through what that approach looked like and what we ended up with spacing wise and setback wise.
Yeah, it was really interesting. So the roof structure that you see here was actually originally a single phase service. It was a second service at the site that got converted over to three phase, and backed up by the microgrid as well. The trees that were there, kind of where the ground mounted system you see is now, were aging and had some disease to them. So they were concerns for other reasons. And there was already a plan to do kind of some selective thinning of that area, to not only protect the, the structure, but also that right of way and the school from damage. So the timing worked out well, that we had an opportunity to bake in some of that work into the kind of co-optimization of the array. I see Craig's question in the Q&A around carports. We had considered a carport. There was a cost element and a geotechnical element. Like I'd mentioned, this was glacial tilt, so the geotechnical analysis was challenging, and we wanted to both make sure that there was kind of the ability to maintain the system at ground level, while also deploy it at a cost-effective way. But yeah, I think like we were fortunate in that we had the setbacks that the county wanted to see. We did have, you can't really tell from this image, but we've got 3 different pitches from the PV here, which actually had some benefit to, co-optimizing the generating capacity of the PV for different seasonality, kind of system optimizations. So yeah, all of that got analyzed and chucked into our optimization model and considered when we were, thinking through the battery system sizing and what we could ensure, both generator size and survivability of the BESS for autonomy.
Lucas is going to move to the next slide. That's sort of a popular word today: controls, controls, controls. But I'm kind of curious about what O&M plan Markus does the community have? Because we can design and develop these systems, we can commission them, but then they have to live on. What does that look like here?
So we have a Sulis Energy has a contract with the Orcas Center to provide ownership and maintenance support of the project, kind of long term. That was part of the requirement to maintain a longer term warranty from ELM itself. So we're providing biannual maintenance on the equipment, testing of the equipment and validation of performance. Both kind of short term and long term.
And we got a few other questions on system layout and kind of controls hierarchy, and I think we can touch on both of those by kind of walking through this block diagram really quickly. So first question we got is this AC or DC coupled? This is an AC coupled system. It's what we see most commonly these days at Mayfield for microgrid setups. Not to say there aren't plenty of DC coupled options out there. Just to give us kind of a lay of the land, what we're looking at here, again, very overly simplified block diagram of this microgrid. Starting from the left, we have our grid interconnection tied in via motorized breaker to our AC panel board within the Orcas Center facility. Underground trenching to an AC aggregation panel that's co-located with everything you see over here. So a motorized breaker to connect and disconnect our generator, our BESS and BESS inverter, our PV array and PV inverter. Our first kind of viewpoint here, we're calling this the morning. So our PV array is just starting to kick online. Our BESS may have powered some of the facility loads overnight, so we're about halfway charged. We're still actively connected to the grid, so this motorized breaker is in the closed position. We progress through the day a little bit. Now we're midday. We've got a grid outage occurring here. So this motorized breaker tied to an electrical relay will sense a grid outage. It'll open this connection to the grid in an open transition. And now we're moving. So BESS and PV are our primary power sources on site. This BESS inverter is grid forming. So that will serve as our primary power source while we have sufficient PV to supply loads, as well as BESS power to supply loads at the Orcas Center. But let's say we get further in the day, now we're toward the evening, our PV array is really winding down, our BESS is starting to drain to a low state of charge. Here's where the controls really get complicated, in that we need to be talking with the generator in real time, looking at the best state of charge, measuring facility loads, and then determining, who is grid forming at that time. So if the best state of charge falls below a certain level, we will tell this motorized breaker to close, and then their generator becomes our main power source. We're now powering the facility with the generator. We're also recharging the BESS with the generator. Once the BESS reaches a high state of charge, we open this motorized breaker and go back to the BESS as the primary power source. So from Mayfield's perspective as electrical engineer of record, I think this was the biggest challenge, was all the coordination involved with relays, breakers, and determining the sequence of operations to make all of this work. But I'll kick it to you, Markus, and you, Aaron, to give us a little bit more flavor on what all went into this project.
Yeah, Markus, I can jump in here because, this is where the microgrid controller that we've developed and been putting in the field. We have over 300 active sites with microgrid controls with very similar setups to this, some grid tied, some completely islanded all the time. And to what Lucas was talking about there, it's a constant monitoring of the entire system. So when we talk about it, it's very straightforward. It's like, oh, if this happens and we do this, but you're constantly monitoring that in milliseconds throughout the entire day. So like the grid outage, there's different types of grid outage. So we're monitoring voltage and frequency from the grid. And we have set points in there that if we see that frequency dip, we'll bolster that with the BESS to stabilize the grid at the facility, or even go offline from the grid because the frequency is so ugly or the voltage is so ugly from the grid. All right, there's different settings to that we work with in different regions, and different utilities kind of have different variations to that. But then in that off-grid situation, talking about bringing the generator up, it's operating our mode of operation from an ELM microgrid control standpoint is to keep the generator happy. People ask us all the time, well, how do you manage the generator? And like, well, what we do is we use the rest of the system to manage to keep the generator happy. So we try to we know from our controls what the optimal run rate is for that generator. And so we run that generator at its happy place all the time. To use a little Adam Sandler in there. We keep it in its happy place. And then we are able to respond very rapidly with the battery energy storage system to what the generator needs. So if the loads spike, generators a lot of times don't like to see a lot of transient loads. So we can respond to smoothing those transient load spikes with the battery energy storage system. If the loads at the facility are lower, and with a traditional generator run, you would run the generator at a lower efficiency, which is referred to a lot of times as lugging the generator, will apply load from the battery energy storage to bring that up so that generator is running at, let's say, 65% or 70% efficiency, which is where you're getting the best fuel usage. The generator's running the cleanest, the generator's the happiest. And then we're charging those batteries, or we're discharging those batteries, which can react in those milliseconds to handle those load shifts and changes. And then to what Lucas was saying, we get the batteries to a certain state of charge, we'll shut that generator off and just have the batteries operate. And all of that transition happens seamlessly. So the folks in the building don't know that it's happening other than the alerts that they'll get from our system. And to the point where we actually had one customer who we put a system in for, they didn't sign up for the alerts. And then they called one day and they said, can you slow your transitions on your system down? And we were like, what? And they're like, well, our power went out today and nobody knew until somebody went out to lunch and saw that the power on the whole block was out. And we're like, well, didn't your alerts come through from the system? And they were like, oh, we never signed up for those. We're like, yeah, we're not going to slow your system down. We'll just sign up for your alerts and you'll know what's going on. So, but we're glad to know that your microgrid worked seamlessly and you didn't even notice that there was a power outage. So, that is, and then that goes too with controlling the PV array as well. So when you're in that off-grid situation, we can also generate power with that PV, but our controller is telling the PV, here's the power output you need to put out. So we'll curtail that PV to match the load and match the ability to charge the batteries as well. So there's a lot of integration. Whenever we actually log into the back end and show people all the numbers and all the communication that's happened rapid fire, they're really amazed because it's, over 1,000 points of data that are being monitored by the system all the time. And then those decisions are being made, in real time with the system. So it's a lot of effort there. Markus, I don't know if you want to add some there, but.
The last thing I would say, we were fortunate that Washington State Department of Commerce was able to grant funding through the Climate Commitment Act for this project. Part of the conditions of that was the kind of decarbonization aspect and impact of it. So they had sourced funding for a generator elsewhere, but hadn't implemented that generator yet. So being able to co-optimize the microgrid system with a future generator really allowed us to dive deeper into a load study and understand what those transient loads were and what the actual ride-through capacity of that generator needed to look like to support the BESS and DER sizing. So it is all in an ideal world, you can implement all of that together and co-optimize it. I know we don't always live in that ideal world, but that was one of the things that made this project successful for sure.
Markus, Aaron, thank you. We're running up on time, so I'm going to try to sprint through these last couple slides. Key takeaways: every microgrid is bespoke. We do have a tendency of working together on projects, and I think the reality is, as you move away from commercial rooftop and maximizing space and adding complexity with storage or storage controls and microgrids, experienced partners matter. For me, particularly filming this project, that social buy-in is a big deal. You can reach Markus and Aaron on their websites down here and their emails. By the way, this project actually won Microgrid of the Year from Solar Builder magazine, which will be announced in December, which is pretty cool. And then last but not least, our final episode of the year, load control, winning energy storage projects through smart design. We have a white paper to dive into. Jacob Betcher, CEO of Mayfield Renewables, and Casey Miller, CEO of Alexity. By happenstance, all three of us live in Bend. It's a beautiful day today. Sorry we ran a little bit over, but it was a great episode. Aaron, Markus, Lucas, thank you for joining us on Dispatches from Energy Transition.
Thank you.
Thank you guys very much. This was great.
Fun conversation. Thanks, y'all.